Hi, welcome back to the second questions for circular motion in a circular orbit. Okay, a satellite revolves around the Earth in a circular orbit of period 24 hours so that the satellite is always at the same point above the Earth's surface. Okay, so this satellite is actually has the period. This is the period of satellite. Is saying that period of satellite. We all know that the Earth rotation also 24 hours for one complete oscillation. So the speed of satellite should be the same as the period of satellite should be the same as the period of Earth rotation, which is 1 day, which is 24 hours. So that it always at the same point above the Earth's surface. So this is what we call geostationary satellite. Geostationary satellite, right? So geostationary satellite means it always above the same point, at the same point above the Earth's surface. Specific location geometrically, geographically, same point above the Earth's surface, called geostationary satellite. Why? Because they have the same period. Satellite and Earth had the same period of 1 day. Means the Earth rotate 1 day, one day. So the satellite also 1 day finish one rotation, right? Now, explain why the orbit must be in the plane of equator. Okay, why the satellite orbit must always on the plane of equator? Do you know one thing? Satellite orbit is always on equator. All satellite, any satellite. In fact, all satellite is always on equator. You cannot find equator, you cannot find other satellite on northern hemisphere or southern hemisphere. There's no satellite at the northern hemisphere or southern, no satellite there. All the satellite concentrate at the equator, above the equator. Okay, do you know that? The reason why, because you see, if on the equator, the center of the orbit is the same as center of Earth. Do you see that? The center here, the center of the Earth becomes the center of orbit. Okay. So we know gravitational force is towards the center of Earth, and centripetal force also towards the center of orbit. If Earth and orbit share the same center, then the gravitational force is equal to centripetal force. Okay? But if the satellite is at the northern hemisphere, the orbit is at over here at the top. Okay? So this becomes the center of orbit, and the center of Earth is off center. Not share the same center, you see? So the gravitational force is towards the center of Earth, but the centripetal force is towards the center of the orbit. So they are not parallel. Gravitational force and centripetal force not parallel. So the gravitational force not equal to centripetal force. This is not right. So that's why the satellite must be at the equator, so that the center of orbit is the same as center of Earth. And then gravitational force will be equal to centripetal force. That's the reason. Yeah. So the reason is because the gravitational force must be equal to centripetal force. That's the reason. Now, B, find the radius of orbit. Radius of orbit. Okay, so want to find the radius of orbit, we are given the period 24 hours. 24 hours is also 8.64 exponent 4 second. Radius of Earth, mass of Earth. Okay, I already summarized all the information here. Right, 24 hours actually is 1 day, which is 24 hour times 60 minutes 60 seconds. We get 8.64 exponent 4 second. So now let us find the radius of the orbit. So the radius of orbit, so this is the radius of orbit. This is the formula for period, and this is the mass of Earth. So substitute all the information we have. Okay, period is 8.64 exponent 4 second, which is 24 hours. 8.64 exponent 4. And then we want to find the radius. Okay, G is 6.67 negative 11. Mass of Earth. Mass of Earth is 624. 624. Okay. So we will get the R equal to, we will get R equal to 4.23 exponent 7 meter. This is the radius of the orbit. Okay, is it correct? Yes, almost. 6.23 exponent 7 meter. That's the radius of orbit. So now find the speed of satellite. Okay, easy. Speed of satellite is square root g m/r. R also is the radius of orbit. So we already get the radius of orbit. So just substitute that for a value. This is the mass of Earth. So what are you waiting for? Just substitute the value. 6.67 exponent negative 11. Mass of Earth. Mass of Earth is 624. 624. And radius of orbit, we got it just now. 4.23 exponent 7. So we get the speed of satellite equal to 3.075 exponent 3 meter per second, which is also 0.075 kilometer in 1 second. Wow, this satellite travels very fast. In 1 second, it's able to travel 3 kilometers. 1 second, travel 3 kilometers. That's very fast. Can you see that the speed of satellite and escape velocity, normally the answer is in kilometer. The answer is kilometer per second. If you get the exponent more than kilometer, it should be wrong. Okay, so you can see the pattern. The escape velocity and the speed of satellite normally is you will get kilometer per second. Okay, exponent 3. If you get exponent 4, exponent 5, no, especially exponent 5 or exponent 6, that is wrong. Yeah, you always get exponent 3 or exponent 4, right? Okay, now the next, we want to find if given the mass of the satellite is 120 kilogram, what is the kinetic energy? Oh, want to find kinetic energy? We can find kinetic energy because we already have the speed of satellite. We have the v already. So now give the mass of satellite. Just use half mv square. Kinetic energy equal to half mv square. So the mass of satellite, yeah, this should be, because we are talking about kinetic energy of the satellite. Kinetic energy of satellite, so this one should be mass of satellite. Okay, mass of satellite should be 120 kilogram. 120 kilogram. Okay, 120 kilograms. So, and then the speed of satellite is 3.075 exponent 3 meter per second. Use meter per second as SI unit. So the answer is 5.67 exponent 8 joule. That's the kinetic energy of the satellite, right? Very high kinetic energy, exponent 8. Wow. So now the next one. Yeah, so just now is 5.67, so 5.70 exponent 8. Yeah, almost the same. Yeah. Now, if a satellite is in higher orbit, discuss how the kinetic energy of the satellite changes. So the question says, if in higher orbit means the radius increase. Okay, the radius increase, higher orbit, how the kinetic energy changes. So, okay, we have the this formula, speed of satellite, square root gm over r. The radius of orbit affect the speed. So the speed which is affected will also affect the kinetic energy. So see what happened. The higher orbit, bigger radius. So bigger radius will have smaller speed. So going far away from the Earth, the speed actually becomes slower. So at lower velocity, lower kinetic energy. That's it. So the answer is the kinetic energy decreases as moving away from the Earth. Okay? In higher orbit, the speed becomes slower. Okay? At higher orbit, further away, the speed becomes slower, lower kinetic energy. So you must support your explanation with formula. You must support your explanation. Question like this, discuss what happened. You must support with formula. Support your explanation with formula. Don't just storytelling. You must support with a formula to explain the changes. Okay? Higher orbit, lower speed, lower kinetic energy. Right? Kinetic energy decreases. So that's all for satellite motion in circular orbit. Hope to see you again in upcoming videos. Bye!